Obra Dinn has one of the most striking art styles ever created, and you would not believe the amount of effort that went in to create some of these effects. For example, here, in this scene of a man striking with a rod, there's an entire 3D scene with a dust cloud to generate the action and momentum. This is used elsewhere in the game as well. This muzzle flash is actually composed of a few elaborate dust clouds emanating from the gun that creates this very dynamic scene, viewable from multiple angles, even though it's actually a static 2D image. In fact, the entire game is modeled in 3D in Maya and Unity, and then an elaborate pipeline of shaders and renderers and other effects are used to create the images that you actually see on the screen. The care and attention that Lucas Pope put into this game is kind of unfathomable without seeing the details yourself. Even these ropes that tie down various objects are procedurally generated, and they're barely perceptible in the final scene. But Lucas kind of had a vision, and he wanted the game to be perfect, so he put all this effort in for things that we would barely notice. And we're so fortunate because he documented his entire process of developing the game on TIG-Source, and I'm going to show you some of my favorite things about the development of the game that you might not have noticed, including things that Lucas spent over 100 hours on that he didn't think anyone would ever see. Everything in the game is in this 1-bit style, which means that there's only black or white pixels, but through a combination of approaches, Lucas creates different effects in different environments that just tie the whole thing together and bring it to life. The art style was inspired by games from the 80s, where developers had to innovate new styles to produce the effect of deeper and richer colors than were available in the hardware. For example, here you can see the palettes of the Amstrad and the Commodore 64, which only had 16 or 32 colors, which despite this were able to create the illusion of more colors using an approach called dithering, which is best explained with an example. So say you have a grayscale image like this, and your goal is to transform it into an image that only uses 2 colors. One approach to do that is just to take all of the colors that are closest to white and make them white, and all of the colors that are closest to black and make those black. However, this doesn't really produce very good results, because no matter what you do, you lose a lot of detail in the image. So the idea of dithering is to selectively push some of the black pixels towards white and some of the white pixels towards black to get that depth effect back. This is one example of dithering that uses an approach called Bayer dithering that gives the illusion of multiple shades of grey when actually we're only using black and white pixels. Obra Dinn actually uses multiple different types of dithering depending on the context. For example, here this man's face is using an approach called diffusion, the clothing is using Bayer, and the light on the wall is using blue noise. Each dithering approach has its own unique style, and Lucas Pope has carefully selected different approaches for different parts of the scene to give the visual effect that he's looking for. Here's how it works. The 3D model first goes through a pass to identify the surfaces, which are distinct from each other. The lighting is then applied on top, and then these are combined into the final effect. One thing that he does very deliberately is to specify that some areas should be purely black or purely white, and you can see that in this example the best. So this shadow here, he specifies it has to be purely black, and these wooden handrails have to be purely white. He also removes some of the lines on the edges to make the effect very distinct visually. So each object on the scene has its own specification for which dithering pattern to use depending on the effect that he's going for. You can see here examples of different dithering algorithms applied to the same image that give very distinct effects. Bayer dithering is kind of the simplest approach to dithering that's used, and it creates this very ordered approach. So pattern of thresholds instead of the simple threshold of, anything brighter than 50% becomes white and everything darker than 50% becomes black. Instead, a different threshold is used for each pixel, so even the same source color can become a different color in the target. Blue noise is another approach that uses a threshold map like that, except this time the threshold map is random. The first approach that people tried for random dithering is to use white noise, which are just completely randomly generated pixels. But the problem with that is that the results just kind of don't look that good. Here's an example of blurring a white noise threshold map, and you can see that even blurred, you get these kind of hotspots of white and dark, which is undesirable in the final image because these patterns are still quite noticeable. So blue noise aims to remove that, and the way that they do it is by taking those light areas and putting some more black pixels in them, and taking some black areas and putting more white pixels into them in an approach called void and cull. And this gives a much more pleasing visual effect than just pure white noise. The other approaches work a little differently to that. Here are some examples from in the game of using different dithering patterns on the same scene. And you can see that the choice of dither pattern actually makes a big difference on the visual effects. So it was important to Lucas Pope that he put the care and attention into deciding which algorithms to use where. One problem with the classical dithering approaches is that they're designed for static images, not for 3D worlds that you can move around in. So they don't perform very well when you move the camera. Lucas Pope had to create his own entirely new approach to dithering that would work in 3D situations. The first thing he tried was to bake the dither pattern into the objects themselves, and you can see that this does stabilize the dither, but it's obviously quite undesirable. The sphere here is just completely out of place in the scene, so he gave up on that. The next thing he tried was to kind of keep track of the dithering from previous frames and use those to influence the dithering from the next frame. You can see that this is an improvement over the original approach, but it creates these kind of visual breaks and warps in the pattern that you can see in the second image here. So the final approach that works really well was to imagine a sphere around the camera, map the dither pattern onto that sphere, and then use that to render the whole scene. And you can see that this is much more stable. And here's a side-by-side comparison of the improvement. Lucas said, "It feels a little weird to put 100 hours into something that won't be noticed by its absence. Exactly, no one will think, man, this dithering is stable as shit, total magic going on here." But the fact is, if he hadn't put this work in, then people would have experienced quite a lot of motion sickness playing the game, and it would have become just a much less enjoyable experience. And I think one interesting thing reading through these blog posts, which we're, again, so lucky to have, is it's kind of clear that Lucas Pope wasn't an expert in dithering or anything when he started this. He just had a vision for what he wanted to accomplish and the determination to keep going and try different approaches until it worked. And I think that's very inspiring and something that we should all take away and try and embody in our work. You don't need to know what the final solution is going to look like to invest the effort into trying, and maybe you'll come up with something completely new and better than what came before. Another advantage of Lucas sharing his whole process out in the open like this is that people gave feedback on the game as it was being developed and on the approaches. And in fact, Brent Wernes, a mathematician at the University of Chicago, chimed in and invented his own new approach to dithering, which Lucas Pope eventually ended up using for the game. And given that the game involves identifying clues based on visual results, it's really important to be able to identify humans from their faces. You can see that Wernes's results are just much better than the traditional approaches here. As the project developed, it got more and more elaborate. Here you can see the ship's rigging is not fixed. It's 3D modeled with joints, so it can respond to the motion of the ocean or the wind or the rain. And when you put it all together, it creates these unbelievable results. I'll put all the sources I used for this video in the description if you want to check them out. Thank you once again to Lucas Pope for sharing all of this amazing information about the game. And thank you to Dama, who created the dithering visualizations. He's currently working on a part 2 for that, so if you want to see that when it comes out, then follow him on Twitter.